All right, let's talk about a problem that drives every single one of us in cybersecurity absolutely crazy. You know the one. You've got the perfect payload, you click upload, the little progress bar finishes, you get a nice green check mark, and then nothing. Poof, your payload just disappears. Today, we're going to put on our detective hats and solve this case once and for all. We're going to trade that frustration for a process that actually works every time.
And this quote it hits home, right? You're chasing a ghost. It feels like you're fighting some incredibly complex, magical web filter. But here's the secret. Most of the time, the problem is way simpler. And honestly, kind of boring. And that's great news, because boring problems are fixable problems.
So here's our game plan, our roadmap for this investigation. First, we'll define the problem. Then, we'll run through a super quick triage. We'll inspect the request itself, learn how to tell the difference between server truth and UI lies, figure out what success actually looks like, and then we'll finish with the one method that will save you from ever wanting to throw your computer out the window again.
Look, our main goal here is to stop doing what I like to call superstition security. You know what I mean? Just randomly trying .php, then .php5, then .phtml, and basically just praying to the server gods that something sticks. No more of that. We're replacing it with science, a repeatable checklist that gives you solid proof at every single step.
This right here is the heart of it all. Everything comes back to these 4 questions. Your job isn't to hope for a shell, it's to prove each link in this chain. Send, accept, store, fetch. If even one of these breaks, you haven't failed. You found the exact point of failure. You found your clue.
Okay, let's get practical. Let's jump right into Burp Suite with a 10-second triage you can run the second an upload feels off. We're not talking about fancy bypass techniques here. We're talking about establishing ground truth. First things first, and it sounds almost too simple, but did the request even leave your computer? Check your Burp proxy HTTP history. If that post request isn't there, you're debugging a ghost. The problem isn't the server, it's on your side. Maybe a scope filter is on, or your proxy is misconfigured. But you're not even in the game yet.
So you see the request in your history. Great. Step 2, send that exact request to Repeater. Don't change a single byte. Now, send it again. Does the response from Repeater match the one you got from the browser? If it doesn't, stop. Don't touch that payload. That difference is your big clue, and 9 times out of 10, it's screaming that you have a stale session cookie or a one-time use CSRF token.
And third, we need to be real detectives. That upload successful message in the UI, it's meaningless. It's a lie. We need hard evidence from the server's actual response. Are you getting back a file ID, a JSON object with a storage path, anything? If the server's response is generic, you have to assume it failed, no matter what the pretty green checkmark tells you.
All right, let's say your session is fine. The request is being sent, but it's still failing. Your brain immediately screams, it must be a filter. But what if I told you the most common reason for failure isn't a filter at all? It's just a broken request. The server's parser takes one look, doesn't understand it, and just throws it away. It never even sees your file to begin with.
And these are the tiny, maddening things that break it. A boundary string that's off by 1 character, a missing line break. But the absolute #1 killer is using the wrong field name. Don't guess and use file or upload. Capture a legitimate upload and look at the name attribute in the content disposition header. Is it file upload, avatar, user/photo? You have to use that exact name. Oh, and don't forget to include all those hidden form fields too.
This leads us to probably one of the most important lessons in all of web security testing. You have to learn to separate what the client side claims happened from what the server side proves happened.
The client side is just theater. It's a performance designed to make the user feel good. All those green check marks and success messages, they're just applause. The server side, on the other hand, that's hard evidence. The HTTP response codes, the file IDs, an actual URL where you can get your file, that is the truth. Ignore the applause. Look for the forensic evidence.
So why does it request work in your browser but fail the moment you send it to Repeater? Well, think of your browser as a helpful little assistant. It's managing your cookies, refreshing tokens, handling all that stuff for you. Burp Repeater, though, it's brutally honest. It sends exactly what you give it and nothing more. If your cookie is stale, Repeater isn't going to fix it. That failure is the clue. It's telling you something important about how the app manages state.
And all of this boils down to a really simple, powerful mantra.
Before you start trying clever bypasses, before you think about double extensions or null bytes, just remember this: auth first, ego later. Get a stable, authenticated, repeatable request working first. Seriously, this simple rule will save you more time and frustration than any fancy payload trick ever will.
So let's imagine you've done it. You followed the steps, you fixed your request, the server accepts your file. High fives all around, we're done, right? Well, not quite. Getting the file onto the server is a huge step, but now we have to ask, what does success actually mean for us? What's the impact? So many of us, especially in labs, get this tunnel vision for execution. We think the only win is a web shell, but that's often not even the intended vulnerability path. Sometimes the win is just reaching the file to trigger a stored XSS in its file name. Or maybe the application triggers some process with your file, like an XML parser, or includes it somewhere, leading to LFI. Don't worship the web shell. Find out how the application actually uses or consumes the file.
Which brings us to our final and maybe most critical section. This is the single most important habit you can build to stop guessing and start solving these problems efficiently. This is the cure for those wasted hours. I call it the baseline method.
The number one mistake, the reason we fall into that trap of superstition security, is that we don't have a baseline. We don't have a scientific control. Without a saved, known good request to compare everything against, every single test you run is just a shot in the dark. It's not science, it's just guessing.
The solution is to create what I call a gold request. The very first thing you do is upload a completely normal, legitimate file through the browser. You capture that request, send it to a repeater tab, and you label it baseline. That is your anchor. Now, for every single experiment, you right-click, clone tab, and you change only one thing. This is how you stop the chaos and start running a real experiment.
And man, this quote from the source material is just so painfully real. We have all been there. You look at your notes and you're on attempt number 17, and you realize you're not hacking anymore. You're just hoping. You're just throwing stuff at a wall. The baseline method is what turns that hope back into a repeatable process.
And when you use this methodical approach, you can go right back to our original proof chain and put a nice, satisfying checkmark next to every single step. You have proof it was sent. You have proof it was accepted. You have proof it's stored and proof you can fetch it. The mystery is gone. All that's left is the data.
So I'll leave you with this final thought. The next time a file upload is failing and you're starting to get frustrated, just stop and ask yourself, are you doing security or are you doing superstition? Are you proving each step in the chain, or are you just on attempt number 17, hoping this time it'll be different? Making that choice to be systematic is what this is all about. Thanks for watching.